Good morning everyone, my name is Scott Somerville. I am the CEO of Apira Group. We've got offices in Brisbane, Sydney, Melbourne and Perth. And today I want to introduce you to our new Class 2 biological safety cabinet complying with AS 2252.2. We're going to go through some of the performance requirements of the cabinet, some of its unique features, and I've got one of my technicians, Curtis Patel, here with me today to go through some of those key points. We decided to develop this cabinet because we saw an opportunity in the market to build something to comply directly with the standards. There's a lot of product coming in that hasn't specifically been built to the Australian standard, and from a technician's point of view, you're quite often trying to set a cabinet up outside of the parameters that the cabinet was designed to run at, and that's particularly a problem with single fan and European cabinets when you're trying to get airflows prescribed in an Australian standard that were never designed to achieve. So we took it on ourselves to work with a manufacturer, and we've built actually 4 prototypes of this cabinet. So it's actually been a 4-year process. It hasn't been easy with COVID getting in the middle and putting a halt to all of that. But we're here now, so it is actually a true twin fan, twin plenum cabinet. So it offers the best protection that we can get in the market. And we're also, from a technician's point of view, there's a lot of features that we've designed into this cabinet just so that it's easy for our technicians and everyone's technicians. Like, there's lots of technicians out there that are all servicing other companies' brands of cabinets, and we wanted the other technicians to look at our cabinet and go, wow, they've really thought about the technician when they designed this cabinet. So that was one of our really key points, particularly with control panels and just trying to make the cabinet easy to adjust when it was outside of parameters. That was one of our key drivers. Okay, in relation to support, another thing that we've found, and particularly with supply chain issues and stuff like that, is just getting parts. So many times, a cabinet will fail its performance requirements and you just can't get a part. And so one of the things that we wanted to do was, every time we order a container of products, we'll also order fans, control boards. The filters that we're using in this cabinet are an American Air filter, which are going to be carried by American Air Filter throughout Australia. So it's not going to be a problem to buy filters, whether you buy them from us or our supplier, American Air Filter. So we're carrying spare control boards, fans. So if a cabinet breaks down, whether we've got it under a service contract or another company has it under a service contract, we want to be able to get that cabinet up and going, in the fastest time possible. So that's been a really big thing for us, is just to make sure that we have everything available. Some of the other things that we've done, which we'll show you a bit later, we've made all the control boards plug and play, all the fans plug and play. So we're evolving the cabinet. Each time we've done a prototype over the 4 that we've built, we've evolved it so it's becoming better and better. And that process won't stop either. I'd like to introduce Curtis now. He's one of our senior technicians. He's been with us for over 10 years. Curtis, can you just talk us through the key features of this cabinet?
Yeah, well, we'll begin with the sash, the glass sash that we have at the front. It's manual, can be operated manually, but also be operated by the motor, an automatic motor as well, that will raise and lower based on the touch screen we have in front of us. The touch screen has features large LED touchscreen that has a display for showing you the airflows, demonstrating the 2 EC control fans as well as the 2 plenums. It's also got active airflow velocity and pressure differential across the filters readings as well.
And what sort of filtration is actually in the unit, Curtis?
We've got 2 H14 class HEPA filters, both for the laminar flow, blowing down over the workspace, and an exhaust HEPA filter on top.
Okay, and they're both standard size AAF filters?
Standard, easily sourced, easily replaced.
So what about the memory functions of the control panel? And you're obviously showing, a whole pile of performance parameters there. Are they in compliance with the Australian standards? And what can you tell us about the alarms that's with the standards, with the high flow alarm, low flow alarm?
Yeah, I'll start with your first point, the memory function. So if there is a power outage, All the settings that have been saved have been preset inside the unit. The airflows, the alarm settings will be saved. As soon as the power comes back on, it will come up with a blackout alarm, but there's no need to reset and recalibrate. It'll be as it was in the previous NADA calibration. Inside the maintenance menu interface, you can easily reset the airflow nominal set points, the speed you want the fan to go at to achieve the performance requirements of the Australian standard. You can easily adjust the alarm set points as well for not only the airflows, high and low flow alarms, but also the loading of the HEPA filter, so that you'll know when the performance of your cabinet is getting outside the Australian standard requirements.
So from a technician's point of view, Curtis, because I know we've put a lot of time into the back end of this, and the controllers and the sensors, the airflow sensors, pressure sensors. What makes this so easy to use compared to what traditionally you see in the market?
The interface is very intuitive. There's not of two parameter controls to change things such as alarms or airflows. You are literally putting in what you want the airflow to achieve, and literally what you want the alarm set points to be at, rather than putting in an additional factor to calibrate between the two. You also don't need a third-party software interface to access the controls as well. We really feel like it's going to be something that our service personnel are going to enjoy working with.
Have an open access control, and for a service technician, whether they're working for us or they're working for a competitor, to turn up and be able to have easy access and support. So we'll be providing support even if we're not servicing the cabinet. Contracts change, they go from one to another. One thing that you can be sure of with us is, if a lab is using a competitor to service a cabinet that they've purchased from us, we'll give full support and training so that they're not always tied to us. I think that's a key feature. People deserve to have a choice. We're backing our cabinet and our support, whether it's under contract for us or not. I think that's also a key feature of why you would want to buy one of these cabinets.
You'll notice that the work zone is all walls, back, both walls, one piece of stainless steel. That makes the job of cleaning and maintaining a clean environment, sterile environment, easy for the users. You're not going to get contamination build up in between joins and cracks inside the work zone space.
Can you talk me through some of these perforations that are in the side of the cabinet and the back, and how they relate to, say, particular performance requirements that are standard with, say, work zone integrity, for example?
One of the main points was achieving a strong containment barrier. One of the most important things for a isolation unit such as a Class 2 cabinet is to maintain all the contamination inside the cabinet being drawn away and not coming from the outside, contaminating the work zone space either. So the design of the cabinet with the holes down the side and the position of the grill at the bottom has been, in conjunction with the twin fan design, achieves one of the strongest inward air barrier flows that we have, as well as the reverse barrier, easily meeting the performance requirements of work zone integrity and the reverse barrier test that Australian standard requires.
So Curtis, can you run us through some of the accessories that are available with our Class 2 cabinet?
Yeah, you can see that we have twin power outlets on that side, and we've also got the option for installing taps for both gas and water inlet inside the cabinet as well. The unit comes standard with those gas tap and tap accessories, and you can install them quite easily. So
Curtis, obviously, scientific staff sit in front of these for long periods of time. What do you think the key advantages of this cabinet are from an end user's point of view?
Yeah, it's got a large work zone opening. There's not a big gap between the where you're putting your arms in and the work zone surface, as well as the large LED display. Easy, intuitive controls. It's easy to follow. And as I showed earlier, the airflow pathways are clearly defined so that whoever's using it is confident in that it's doing what it's designed to do.
And can you talk me through the alarms? Because obviously this is a primary containment device.
Yep.
So what have we done with the alarm functions that the operator will get comfort out of knowing that they're sitting in front of something that's going to alarm when it's supposed to alarm, and what are they going to see when it does alarm or hear?
Yep. We've got two types of alarms. We've got the airflow alarms for both the laminar flow and the exhaust, which is directly correlated to your inward barrier. When those are falling outside your parameters that you set inside the maintenance menu, the NADA certified technician will set for you, it will alarm. It's also got pressure sensors that go across the HEPA and the exhaust filter, so you can quickly work out when your filter is becoming loaded and it requires replacing.
So Curtis, obviously these devices have ultraviolet lamps, which are known to be quite dangerous, and the standard requires that there's an interlock function in there. Can you explain how we've done that, and and what modes it works in and what it doesn't work in, and when it does work, and all of the features of the ultraviolet lamp?
Yeah, definitely. As you say, UV is something that's dangerous both to a person's exposed skin as well as their eyes. So the cabinet's been designed with interlock features to prevent people from being exposed, the users being exposed to UV. It works in two ways. It won't turn on while the fan's running, and it also won't turn on while the glass sash is open. So the glass sash has to be lowered completely all the way to 100% closed position, and only then can you activate the UV.
Okay, fantastic.
If I go to open it again manually, it automatically turns off.
Okay.
There's no way of being exposed to UV accidentally.
Yeah, okay, and that's a safety feature that's required within the standards. Okay, so now we've been through all the finer features of our cabinet. It's something that we're very proud of at Opera. It took us a while to get this project going, with 4 prototypes delayed with COVID, but we're here now. Meets all the performance requirements of 2252 Part 2, which is what we set out to do initially. We are going to continually evolve this cabinet, but where we are now we're very proud of, and we think it meets a price point that researchers in Australia will really appreciate. So if you want to find out more about this cabinet, or you want to come and have a look at one, just jump onto our website, opera.com.au. All the contact details are there. We've got stock in most centres. So yep, give us a bell, reach out and come and have a look.